Okay, so my project is Independent Events by Alexandra Gonzalez. Okay, so what is independent events? An independent event is when two elements are independent with one another. Basically, this means in probability that one event has no way of affecting the probability of another event. Okay, so the history behind independent events is discovered in 1738 by De Morbier. De Morbier said, when they have no connections with one another is an independent event. So the TEK I used is TEK 760, which is basically 7th grade, section 6, part D. And it states, proportionality, the student applies mathematical process standards to use probability and statistics to describe or solve problems involving proportional relationships. The student is expected to make predictions and determine solutions using theoretical probability for simple and compound events. Now, the example I'm going to use to show an independent event is basically having a coin and a die. So we have two independent events, which is our die and a coin. And let's say we roll the die and flip a coin. So my question is to y'all to think about. Me rolling a die, would it have any effect of me getting a heads or a tails on a coin? The answer is no. Rolling a die does not affect the chances of you flipping heads or tails on a coin. And the reason is because they're two different things. A die is its own thing, and then a coin is its own element. So they're two independent elements. We're going to see a video of me demonstrating why this statement's true. So I'm going to demonstrate independent elements by showing the example of a die and a coin. Now I have a die, and me rolling this die is going to have no effect of me getting a heads or a tail on a coin. So if I roll this die, I get a 2. And if I flip my coin, I get a heads. The die has no effect of me getting a heads or a tails on the coin because they're two different things. Or the coin won't have an effect of me getting a number by flipping the coin because there's no numbers, there's only a heads or tails, and the die has numbers. Alright, so we're going to try this example in math. So we're going to see how it all connects. So, the probability of an event happening, which gives us our fractions, the number of ways it can happen over the total number of outcomes. So here's our question. What is the probability of getting a head when flipping a coin? Now, the numbers of ways it can happen one time, because on our coin we have a heads and a tails. We only have one tails and one heads. So the numbers of ways it can happen is 1 by getting 1 heads. The number of outcomes for it to happen is 2 because when we flip our coin, we can either get a heads or a tail. So the probability is 1 over 2, which is 0.5. So basically a half. Now, let's try this independent event in multiplication. So what is the probability of getting 3 heads in a row? So we know the probability of flipping a head has 0.5. For 2 flips, we're going to have 0.5 times 0.5, which gives us 0.25. Now, if we flip our coin 3 times and we get 3 heads, we have 0.5 times 3, which gives us 0.125. Is it possible that this can happen? Yes, most likely no, because there is a probability that we could get a tails when flipping our coin. And that is the end of my presentation. I hope you enjoyed it. The information about independent events, and I hope it was informational.